Good morning to one and all. I welcome you all for the today's morning session. So I'm Raju Patil from Department of Mechanical Engineering, Angadi Institute of Technology and Management, Belgavi. I welcome you all for the today's session. So today in Module 2 in Energy Engineering, Module 2 I will be discussing about cooling system. Okay. So what is cooling system? In an internal combustion engine, the temperature of gases inside the engine cylinder may vary from 35 to 2750 degrees Celsius during the cycle. Okay, if an engine is allowed to run without cooling, the walls, cylinder and piston tends to assume average temperature of gases to which they are exposed, which may be order of 1000 degrees Celsius to 15 degrees Celsius. Obviously, at such a high temperature, the metals will lose their characteristics and piston will expand considerably and seize the liner, and all the lubricating oil will begin to evaporate and both cylinder and piston may damage. Okay, in view of this, part of heat generated inside the engine cylinder is allowed to carry away by the cooling system. Okay, why do we need the cooling system? Needs of cooling system in an engine, that is, first one, expansion of piston in cylinder may result in seize of piston. Second one, overheated cylinder may lead to pre-ignition of charge in case of spark ignition engine. Okay, and third one, high temperature reduces strength of piston and cylinder liner. Okay, fourth one, physical and chemical changes may occur in lubricating oil, which may cause sticking of piston rings and excessive wear of cylinder, as well as the piston rings and piston. So it may be a heavy loss, so there is a necessity of cooling system over here. Okay, next one, methods of cooling system. The important methods of cooling systems are air cooling system and water cooling. That is air cooling, liquid, and second one is liquid cooling or water cooling, you can say. Okay, first of all we will discuss about air cooling. In this method, heat is carried away to their to the air flowing over and around the engine cylinder. It is used in scooters, motorcycles, etc. Here fins are cast on the cylinder. You all can see the fins are cast on the cylinder. Here fins are cast on the cylinder. Scooters, motorcycles, etc. Here fins are cast on the cylinder head and cylinder barrel, which provides additional conductive and radiator surface. The fins are arranged in such a way that are at right angles to the cylinder axis. You all can see the fins are set at right angles to the cylinder axis. Okay, advantages: the design of the engine becomes simpler as no water jackets are required. Absence of cooling pipes, radiators, etc. makes cooling system simpler. Installation of air cooled engine is simple. The weight of the air cooled engine is less than the water cooled engine. Engine is not subjected to freezing troubles, etc. usually encountered in case of water cooled engines. Disadvantages: the movement is noisy, non-uniform cooling system. Output of air cooling engine is less than water cooled engine. Maintenance is not easy as compared to liquid or water cooling system. Second one, next will be proceeding with liquid cooling or water cooling. In water cooling, the cooling water is initially treated to remove impurities and then pumped to the overhead. Remove the impurities and pumped to the, you all can see this overhead tank mentioned here. We'll be discussing now liquid water cooling or water cooling. In that, impurities and then pumped to the overhead tank. It is pumped to the overhead tank. This is the overhead tank. Okay, cooling water to the engine around the cylinder flows through the cooling jackets. Okay, through the cooling jackets, absorbs heat and get collected in a hot well. Get collected in the hot well. This is the hot well where the water is get collected. Okay, the hot water from the well is pumped to the cooling tower and sprayed from the top. This is the cooling tower, and it reaches to the cooling tower and it is sprayed. This is the position where spray up is going on here, you all can see. Okay, sprayed from the top. The water flows downward through the baffles and the air is supplied from the bottom, which carries heat from water. The is cold water is collected at bottom of cooling tower. Cold water which is pumped back to the overhead tank for recirculation into the engine for cooling. Purified water is periodically added to hot water well to make up the vaporization losses. So next we'll be discussing about liquid cooling or water cooling. Further, these are classified into natural circulation cooling system and forced circulation cooling system. First of all, we'll be discussing about natural circulation cooling system. In that we'll be discussing about thermosiphon cooling system. Okay, so this is the thermosiphon cooling system sketch, you all can refer here. This system works on the principle that hot water being lighter rises up and cold water being heavier goes down. In this type, radiator is placed at higher level than the engine. A radiator is placed at the higher level from the engine for easy flow of water towards the engine. Heat is conducted to water jackets from where it is taken away due to convection by the circulating water. As water jackets becomes hot, rises to the top of the radiator. Top of the radiator means here it rises. Okay, here it rises to the top of the radiator. Cold water from radiator takes place of rising hot water, and in this way circulation of water is set up in the system. This helps the engine to keep in working temperature. Okay, disadvantage of the thermosiphon: rate of circulation is too slow. Circulation commences only when there is a marked difference in temperature. Okay, next we will be discussing about forced circulation system. That is, in that forced circulation cooling system, based on methods of circulation of cooling water, we have open cooling or single circuit, or closed cooling or double circuit. Okay, so first of all we will be discussing about this open cooling or single circuit. Okay, so in this cooling system, water after absorbing heat from engine is cooled. From the engine is cooled. Engine is cooled in a cooling pond. You all can see the water passes from the engine to the water pond. This water pond, when it reaches to the water pond, it cools and recirculates back to the engine, and once again it recirculates to the back to the engine. You all can see here, this is the engine. The advantage of this system is that it is simple and economical, but leads to corrosion of cylinder. Okay, second one, that is closed cooling or double circuit. In this system, the cooling water flows in a closed circuit. Okay, and gives out the absorbed heat to another circuit of water through heat exchanger. You all can see the heat exchanger placed in between this engine and the cooling pond. Okay, the heat is from the engine, the heat goes to the heat exchanger, and then the water is passed to the cooling pond. Okay, advantages of this system is that closed circuit with purified water does not harm the engine jackets, but system is complex and expensive. Okay, so next we'll be discussing about thermostat cooling system. Okay, this thermostat cooling system, this system is similar to in construction to the thermosiphon system, except that it makes use of centrifugal pump to circulate the water throughout the water jackets and radiator. Okay, so how we will guess that thermosiphon, how we will differentiate that thermosiphon cooling system and thermostat? That is, in thermostat cooling system there is a water pump, and in thermosiphon there is water pump is not available. Okay, so thermostat in that first one we'll discuss the parts of the thermostat cooling system. That is water pump. This is a centrifugal pump. It is centrally mounted at the front of the cylinder block, and it is usually driven by means of belt. Okay, it's water tank. Okay, and next one, that is fan. Fan is generally mounted on water pump pulley, although on some engines it is attached directly to the crankshaft. It serves two purposes in cooling system of an engine. First one, it draws atmospheric air through radiator and thus increases efficiency of a radiator in cooling hot water. Second one, it throws fresh air over outer surface of an engine, which takes away the heat conducted by engine parts and thus increases the efficiency of the entire cooling system. Okay, next one, next important part, that is radiator. Purpose of radiator is to cool down the water received from the engine. Radiator consists of main parts, that is upper tank, lower tank, upper tank, lower tank. Here you all can see the lower tank, upper tank, lower tank, and tubes. You can see the tubes here. Okay, upper tank, lower tank, and tubes. Hot water from upper tank, which comes from the engine, flows downwards. Hot water which comes from the engine, it comes from this upper tank. Okay, this is the upper tank. Okay, which flows down through the tubes. Okay, heat containing in hot water is conducted to copper fins provided over tubes. Copper fins are provided in the tubes. As overflow pipe is connected to the upper tank, permits excess water or steam to escape. This you all can see this above the upper tank there is a overflow pipe. Whenever the radiator overflows, the water comes up above this overflow pipe. Okay, above this upper tank. Next we discuss about thermostat valve. Okay, what is this thermostat valve? You all can see it is placed near the bypass. Okay, thermostat valve, it is a kind of check valve which opens and closes with the effect of temperature. It is fitted in water outlet of the engine. During warm up period, the thermostat is closed and water pump circulates water only throughout the cylinder block and cylinder head. When normal operating temperature is reached, thermostat valve opens and allows the hot water to flow towards the radiator. Okay, with this we end of today's session. Thank you for the today's session. If you have any doubts, you can call me. Thank you.